All right. Excuse me. I think we should get started here. Okay. So, good morning. Morning. So this is week 3, right? We're in the middle point of our class. A few things before we start here. For this week, we have a PA 3, right? We have a PA 3. So make sure you start on that early. That's PA 3. It is due this coming Sunday. The other thing is we have a midterm tomorrow, right? The midterm is open book, open notes, open Python tutor, open Python, but it's not open to internet search. It's not open to collaborations, right? So that's the midterm. Midterm is on Gradescope. It's all multiple choice. It's a midterm is all multiple choice. It's on Gradescope for 80 minutes. So tomorrow you find the 80-minute period to do the midterm. I also have a sample midterm. I think we have a couple sample midterms. So there is a spring 2021 midterm. This was on Canvas. You can see the answer. So this one doesn't have the answer. This one has the answer in it. So it's if you want to practice. We have a fall 2021 midterm. This is closed for closed notes exam. And we also have a fall 2021 midterm 2. So the coverage of our midterm is going to be slightly different from what they have in here. Let me see. We may not have covered 2D list of tuples, but it's something like this may appear in there. Okay. So you can see the solutions from them. Okay. The plan for today is we will kind of talk about introduction to tuples and do a few demos of how to process pictures, right? We're done with the fundamentals of coding like loops, like if else statements, lists, right? Now we're kind of getting into a small application of Python, which is picture processing. For the midterm, everything that we cover from day 1 until the end of the day today may appear in the midterm. Okay, so that's how you should prepare. The class that we have today may not last 3 hours. So I will be here, and if you have questions, so once we finish the material planned out for today, what we'll be doing is we will be basically, I will leave the time for you to practice the midterm if you want to, or if you want to leave and work on the midterm preparation yourself, that's fine. I'll be here until the end of the class. If you have questions, I'll be happy to answer them, but I want to kind of give you as much time as I can to prepare for the midterm. Okay, that is the plan. Okay, that is the plan. You are more than welcome to stay here and just work on those sample midterms. If you have any questions, you can ask me. Either way is fine. Okay. First, are there any questions folks want to ask about the midterm before we get started with the material?
For the midterm solution, like, you posted some practice midterms. On one of the solution pages, I'm kind of confused as to how to know which, like, if the answers are right. Like, can you go to the, I think it's the spring 21. Oh no, yeah, that one, the one you were just on. That one, I'm kind of confused as to how to know if the answer is correct or not.
If the answer is correct or not. For example, 1, A to F is 3 out of 3. The correct answer is int, float, string, float, int. That's what the question is about. So those are the data, and then you may see A to F. That's what we have. G and H. I think. Let's see what G and H. What does it say? But G and H is string error. That's how. So the correct answer are all written in here. And the other ones are just rubrics to say, okay, how do you deduct points? So is that clear?
Yeah.
Okay. Yeah, just look at the correct part. That's the correct answer.
Okay.
Because these ones were in person on paper, so we were grading it on Gradescope, and these are like how we penalize people if they make a mistake. That's the rubric. Negative points. Any other questions? All right, then let's look at the material for today. Okay. So today we will get started with picture processing. Okay. And also for PA3, you're gonna need to process tuples. So it's useful that you know what a tuple is. So a tuple is a group of data, just like a list, right? A list is a sequence of data. A tuple is also a sequence of data. But the major difference between a tuple and the list is tuple is a small number of elements together. So what does it mean? In general, tuples aren't too long. Like you may have a tuple of two things. That's something you can think of, right? You say location equals to this. Tuple is an object. Okay, so location is a reference variable that points to this object 3249. So you may have a tuple of two things, and you use parentheses to create a tuple. So this is the heap. So this is the heap. And this is the object. Okay. So you can also have a list, right? You can say location 2 equals to a square bracket 3249. Then you just created a list object of 3249. So what's the difference between them? Number one, the list can be much longer. You can append more things to the list. You can remove things from the list. You can do that. Not on tuples. Tuples, they are small. Like you may have like maybe no more than 10 elements in the tuple in general, right? And then tuples are immutable. So this thing can't be changed. If you say, let me try to change, so it's the official name is called immutable. The meaning is you cannot change this tuple from 3249 to 3349, for example. You can't. Once this tuple object is created, it stays put. It's like a constant. Okay. So that's kind of the major difference between a tuple and a list. It looks like tuples are not as flexible as a list. Yeah. So then why do I need a tuple? It's small, it's immutable. What's the point? The benefit of using a tuple is because it's immutable, it's easier to read from a tuple and process it. In other words, you have something more basic compared with the list. Just for example, some of your parents or grandparents may have like an old school car that is in the 1950s, 1960s, those classic cars. Those cars, in fact, they don't break down often compared with like the modern cars that maybe Tesla, right? If there is a small problem with the computer software, the Tesla, you may not even to open the door of the Tesla, you know? But those old school cars, sometimes they last forever. It's just because something that is more basic, sometimes it's easier to process it. So it's the speed for you to say, let me read from a tuple is faster than the speed to say, let me read something from a list. Okay. And also tuples in general are small. So you may say like location, geolocation, latitude, longitude. You create a tuple, you send it around, you process them. It's pretty fast. So it's like overkill. If you say I have a list with only 2 things in there, that's not as useful as a small tuple. Okay. So that's the difference between a list and a tuple. The way you can access individual elements of a tuple is like this. You can say location 0, this will give you 32. Location 1, this will give you 49. So in other words, the elements in the tuple also is indexed. It starts from 0. Any questions about like what a tuple is and why we need a tuple?
Well, I have a question.
Okay.
So a tuple it uses parentheses instead of brackets.
Yeah.
Okay.
Any other question? All right. So let's look at this one. Create a tuple. I did this. I print the location. What will happen? Let's vote in. All right, vote in. All right. So the choices, the most popular choices are D and E. If you look at it, we pretty much have a tie. The answer is you can't change a tuple. So the answer is E. Is it why? Because you are trying to change the first element from 11.93 into 13.61. This is can't do it. You cannot try to change the value of a tuple in there. Then what's the point of having location 1? You can read from a tuple, but you can't write to a tuple. Okay, just like you borrow a book from the library, you're not supposed to write on it. You can read the book, that's fine. Right, so in here, if you say print location 1, that's totally fine. You print out 11.93, but you can't say, let me change it into something else. That's not allowed. Another question that some of you may have is, well, what if I want to change it? Is there a way? There is a way. You create a new tuple. Just like if you say, I borrow a book from the library, I want to write on it. What can I do? You buy your own book. Buy a copy of the book, and you can do whatever you want to do. Okay, so you say, I can create a brand new tuple. You can say, I want to change the second thing to be 13.61. You say, let me just create a new tuple then. You can say location 0, comma, 13.61. This would create a new tuple. And that's fine. You just have a new tuple. You can't say, I create a tuple and change. And when we say tuples are immutable, we're really talking about the object itself, not the references. The reference of a tuple can point to any tuples. It's fine. It's just the object you can't change. Are there any questions about this?
So what does the second line do? What does the second line do? Like the location index 1 equals 13.61.
You are trying to change location 1, which is this value, into 13.61. You can't do that.
Okay, so it would just give an error.
This is the part
Okay.
that will give you error. Any other question? All right. How about this one? What do you think will happen? This one is a little bit complicated. Did I click? This one. Okay, vote in whenever you're ready. What would you say the answer is? All right, we'll stop the vote. Stop the vote. Let's say A and B are the most popular one. Okay, so and someone say it's gonna be error. Okay, let's check. Are we trying to change any tuple object? If we try to change a tuple object, definitely you're gonna see error. Okay. There's another question. Do you always have to use the location? No, you can name it anything you want to. Okay, so it's just in here, just the example in here, use the location. So line number 1, we created an object on by location 12.83, 11.93. And then we say AB equals the location. What does this one do? You basically, this is kind of called unwrap. You unwrap a tuple into two things. The effect of that is A now equals to 12.83, B equals to 11.93. That's what it is. So you unwrap the tuple. And this part is a weird operation, but this one is allowed. Is basically swap A with B. You are swapping A with B. After this second line, A is now 11.93, B is 12.83. That's kind of a Python specific way for you to swap two variables. And then you say, I create a new tuple with AB. In other words, 11.93, 12.83. I created this new tuple and then let location point to it. When I print it out, it's going to be A. So there are multiple things going on by looking at these statements. Unwrap, if you have a tuple, you have three things. For example, you can say A, comma, B, comma, C. That would unwrap that tuple with three things into each of these individual variables. If it's a BA equals AB, you swap these variables. You can also think you are assigning the value of A to B, assigning the value of B to A. Okay. This part is creating a new tuple. We are not changing any of the existing tuples. And let the location point to it. When you print out it, it's going to print out the location. The value, which is 11.93, 12.83. Questions about this? All right, let's do some exercising here. It looks like I already have some solution here. Let's try to do a coding challenge. How can I have the solution? Nonetheless, week 3 Tuesday, coding challenge 1. Let's try to do this yourself and see if you can do it. So this is a practice, okay? So you want to write a function, this function, that you are given the weather, the temperature of 3 cities, Miami, this is the first row, all in Celsius. This is in with Cleveland, which is up in the north. This is in San Diego, the 5 days a week, right? So given this 2D list, 2-dimensional list, you also are given this day, which day we are looking at. You are supposed to return the data as a list, like for day 0, for example, 2309. So it's like you are returning the first column, and similarly the next one. Okay. So this one is not necessarily about tuples. In the next coding challenge, we're gonna see a tuple. Okay. So let's work on this practice just to manipulate the list. That's what you need to do for PA3 too. Okay. So let's work on this. This one would return the column. And be careful if you are given the illegal thing, illegal day, then you're gonna output -1. Okay, so can you do this yourself? You can see the link to the coding challenge in the Zoom chat. If you're done, vote in. Okay. Don't look at the PDF. I think the PDF may have a solution there. Try to do it yourself. Try to do it. How do I manipulate this 2D list? In fact, it's a nice 2D list. It's like a rectangular shape. Not every 2D list is a rectangular shape. Two of us are done. Give you another moment, another minute. All right. So let's solve this one together, right? So if you're given a problem like this, how do you approach it? The first thing is you got to know I need to grab the columns, right? So how do I grab the columns in here? You just have to go through each row and they are looking at the same index number. That's it. And that index is this day. Right. So since it's weekdays, right? 0 to 4. So if day is less than 0 or day is bigger than 4, return none. That's the error checking. Yep. And then what I would check is now I need to build up a list. And this is how you return a list, right? Just square bracket. The first thing I need to give is data 0 day. The 0 day is whatever is in the zeros row, right? Because this is a 2D list. So this is data 0. This is data 1. This is data 2. So that's it. Data 1 day, data 2 day. And I'm done. So if I say get a day's weather, I pass in I pass in data. Sorry, this is W data. The parameter that I'm using is W data. Pass in data, pass in like 2. I'm supposed to get 25, 11, 25, 1, 11. We print out whatever I got back. We run it, Python cc1.py. That's what you got here. Any questions about this part? So you want to do error checking first, and then just build up a list because it's so straightforward. There are only 3 cities. If you say there are a lot of cities, that's when you have to write a loop, right? So if there are n cities, I don't know how many cities there are. I just want to know the temperature on a certain day. Then if that's the case, what you want to do is you want to say result equals to an empty list for each row in data. You're gonna say result dot append row on this day, and that's it. In the end, you're gonna return result. This would allow you to say, what if I have more than 3 rows? Then you just say for each of the row in the data, I'm gonna grab the corresponding day in that week and then do it. Any questions about this? This code is more flexible than the other one. 。 . 。 。 。 。 。 。 . 。 . 。 。 . 。 。 . 。 。 。 。 。 。 . 。 。 。 。 。 。 。 。 . 。 。 。 。 。 。 。 。 。 。 。 . 。 。 . 。 。 . 。 . 。 . 。 So that's the first coding challenge. The second coding challenge is this one. Okay. So you have a list of student scores. This is the list of the first score. Let's see. Sorry. This is the list of lab 1. This is the list of lab 2. This is the list of lab 3. Okay. What you want to do is you want to calculate the average of each lab. In other words, you want to calculate the average of this one. This one equals to 77. The average is 77. So the average of each column. Okay. So how do I do this? How do I calculate the average of each of these data? And this is a list of tuples. And this function should return the result as a tuple. So the result should be a tuple. How would you do it? If you say I need to create a tuple and return it, but I need to build up this tuple as I go, a lot of times all you need to do is to create a list, build up the list, and in the end, just typecast it into a tuple. So if you have a list, for example, you have a list L, say I want to change it into a tuple. You just say tuple parenthesis L. This would convert that list into a tuple. That's all you need to do. Okay, so when you're writing this function, it's better that you create an empty list and then start to put things in there. And then before you return, you just return the typecast result of this list. All right, so work on this one, please. Let's see how long it's gonna take for you to finish this one. Vote in once you're done with it. Okay. The link to this one is the link to the second challenge is in the Zoom chat. Work on this one. try to work on this. Give you another 90 seconds, then I'm gonna write it together. All right, let's solve this one together. Okay, so calculate the average of the scores. So we'll look at the first column, the second column, third column, fourth column, right? If there are errors, we always have to look at errors. If the number of grades in the tuple is different from others, then we should just say we quit, which is return none, right? So in here, how do I know how many data in this tuple? We can try this. Okay, we're assuming that this grades is not empty, but we can check if the size of grades is empty, or well, let's just say if this is empty, then we should return none. Right now it's not empty. We can know how many things there are in the zeroth element now. Let's say number of columns equals to the length of grades 0. Right, that will tell me how many things are in here. The length of a tuple tells you how many things there are in there. And then I'm ready to start to process it, and I will keep an eye on this thing. If I see any problem, I would just return none, right? So let's get the ball rolling. The result equals the empty list, right? We cannot create an empty tuple and change it, right? Tuples are immutable. So we say for each row in grades, and this row is a tuple, right? So we'll check if the length of this row is different from the number of columns that we have. We simply return none. Right, this is the error checking. If there is no error, what I need to do is I need to basically add up all these things in here. So let's see, for this row, it looks like we need to say for each of the columns, right? For each of the columns. So we may have to do an outer loop here. Is there a way I can avoid it? Okay, so you know what? Let's see. What's the best way? So we say for each of the columns in here, for each row, we can add these things to what's the easiest way? Yeah, let's just do this, right? So the easier way is I'll just add all these things to my result elements. So initially I want my result to have a bunch of zeros, right? I want my result to have a bunch of zeros. So dot, let's see, what is the function that would allow me to insert a bunch of, let's see. No, I'll just use the for loop then. For I in range of number of columns, I'll just do result dot append 0. I'll just create a bunch of zeros in this result. And now I would just, for I in range of number of columns, I'll just add it to, so result I plus equals to rows I. So now I just added this whole row to the horizontal cell in result. For the next thing, I'm gonna do it. And then once I'm done with this part, I just need to calculate the average for I in range of number of columns. I would just say row result I divide equals to number of rows, right? So it's not the number of columns anymore, the length of grades. And then I'm ready to return typecast this one as a tuple. I think this one would work. So this part is to initialize the whole result to have a bunch of zeros. Basically, the effect is the result would be 0, 0, 0, 0. That's what it's gonna have. And then in here, this is the error checking. Other than this, I just add up each of the elements from here into the corresponding cell. And this part is just to calculate the average. So if I run this code, that should be the answer. So the average of each column. Questions about this? It's a slightly more complicated, but there are many ways to do it. You can have another nested for, like you say, for each of the columns. You add up column by column, and then divide this. So either way is fine. Questions about this? All right. So that is our 2 coding challenges about how to use tuples. Okay. For your PA, you're gonna process lists and tuples, lists of tuples. You follow similar ideas. Okay, follow similar ideas. The second part for today is about pictures, images. Okay. So this is the core of our class for the almost next weeks. Okay, so like for the second half of the summer session. So we're gonna process images, but what is the image? You can think an image is a grid of pixels. Okay, so you know the width and the height of the image. The width of an image is how many columns you have. The height of the image is how many rows you have. And as we already know, for 2D tuples, 2D lists, when you think about the 2D list as a rectangular shape, you are looking at the number of rows by the number of columns. So just be careful in here. It is not X, Y. It's not like X coordinate, Y coordinate. When you try to access a pixel, it's always row, column. If you use XY, sometimes you just got them the opposite way. You got to be very careful in here. Okay. If you think about a grid of pixels, each pixel doesn't have any variation of colors. It's a solid color. So we normally use RGB to represent the color. So for redness, it goes from 0 to 255. So if everything is 0, you're looking at pure black. If everything is 255, so there's redness, greeniness, green, and blue. So if everything is 255, then you're looking at white. But if you say, I want to have a pure red, if you only have red as the maximum amount and blue as the smallest amount, this is pure red. So if you consider the total number of colors, if you use RGB to represent it, it's 255 times 256 times 256 times 256. That's about 2 to the power of 24, which is about 16 million colors. So if each color channel have 256 levels from 0 to 255, you are looking at about 256 colors per channel. 256 cubed is 16 million, around that number. So it's quite some variation of colors that we can create. Okay. So in our program, when we look at a pixel is made of red, green, and blue. We use it as a tuple. So R, G, B. This is a tuple. So the first value will be the redness. The second element is green. The last element is blue. Okay. So we already know what this color is. We know it's red. How about this one? What is R is 255, G is 255, B is 0. What do you think this color is? Voting on this choice. Okay. You basically have a lot of red. What is this color? A lot of red, a lot of green, but no blue. All right, there's really no signs in here, right? Just mix them together. I think you get yellow. Where's that thing? So it's 255, 255, 0. It's yellow color. Yeah, that's all. So nothing scientific. It's more like just color mixing in here. Okay. And for the last one, before we have a break, what is the value of for black? For black is all zeros. No color on all the 3 channels. That's when you have pure black. Pure white is all color channels are full blown. That's when you have pure white. This is white. Okay. Any questions about RGBs? All right. So let's take a break. We'll come back and we'll talk about picture processing a little bit more. Okay. So break time. Come back 12 o'clock. Come back 12 o'clock, please. All right. Let's get ready to come back in 1 minute. Okay. We'll start at 12. All right, so let's get the ball rolling here. So we talk about RGB values. I get rid of this thing. Let's see. I don't know. This is pretty annoying. Yeah. Nonetheless, okay. So, when you look at the picture, each picture is made of pixels, right? So if you look at this picture, how many pixels are in here? How many pixels are in here? Let's do a quick vote on this one. So you know the width is 7, height is 9. Have these red pixels in there. How many pixels are in this picture? Okay, so based on the vote, a lot of us said D, that is correct, 63 of them. Right, well, there are 63 of them. It's not just about the red pixels, right? So it's the whole thing is a picture. So when you look at picture, it's a rectangular shape. You may say a picture that looks like a oval shaped, but indeed everything is rectangular shape in here, except you just have like colors at certain pixels. The other maybe just background color, like transparent color or white color. Okay. So in here you have 73 pixels, 63 pixels, which is 7 times 9. Okay. When we try to process pictures, in general, we try to change the color of pixels, or we try to copy a pixel from one spot to the other. Okay. So how do we change a pixel? For example, you say this, I want to make this pixel redder, like more red. How do I do it? Because pixels are immutable. You cannot simply say, I will change this corresponding location. I will change this pixel's 0th spot to be 255. You can't do that. So normally what we do is you have a pixel. We'll first unwrap it. So you can say RGB equals to this color. Or you can simply do this thing. RGB equals to orange. This would automatically unwrap the RGBs into these 3 variables. And then you can do something on RGB. You cannot change orange directly. You cannot change that tuple object directly. But once you unwrap it, you basically copy out the data from that tuple. You can manipulate any of the RGBs any way you want to. Then you make them to form a new tuple and do it. Okay. So that's in general how we do it. If you look at this one, what's going to be the value of red in the end? If you say by any means we are changing the a tuple, then you may vote for D. Yeah. So what would you say the answer is for this one? All right, a lot of us voted for B. Let's check. Right, so it's going to be 255.00. You have orange equals to this thing. So orange is pointing to this tuple. Right? If by any means you are trying to change these values inside this tuple, you are in trouble. Right? So now we say R equals to the 0th element, so R is 255. G is 100, B is 0. And then we say G equal to 0. We wiped this value into 0. And then we say red equals to RGB. So red is now pointing to a tuple made of the values of red R, which is 255, G0, B0. So red is this thing. Any questions about this? So B is the right answer. All right, how about this one? Is this exactly the same as the one above? No. No. I instead of changing it to red, instead of saying RGB equals to red, I'm saying RGB equals to orange. So this is the change. So what's gonna be orange after this code runs, or if you think there's gonna be an error? Vote in. Okay, whenever you're ready. All right. So a majority of us voted for B, but like about 40% of us also voted for D. So well, everything else is being the same. I think the concern is what's going to happen if I say orange equals RGB. If you look at the pattern above, right? If I say now orange equals to RGB, which is this new tuple, orange now points over there. Orange used to be pointing to this tuple. It just, this link is cut. Now orange is pointing to this object. So isn't tuples immutable? Tuple objects are immutable. Orange is a tuple reference. A tuple reference can change to point to different tuple objects, but you cannot change this object in here. This part is totally immutable. We are changing orange, which is this reference. So you must differentiate object from the reference to an object. We are saying tuple objects are immutable. Okay. So for those of us who voted for D, make sure you understand that this is okay. This is okay. Any questions?
I'm kind of confused. Like, how's orange the first time? Where it's 255, 100, and 0. If that's a reference, how is the orange equals RGB also a reference? Like, how does that not give out error?
Why do you think it's going to give you error?
I thought it was gonna be an error because, like, since you can't change tuples and orange is like the name, like it's the same variable, or like, yeah.
I think there is a confusion here. Just imagine in this analogy, right? I'm a human being. right? So when we say, well, human beings are immutable, it means you can't change this human being. You're saying, oh, orange is the name of that human being. Well, a human being can change their name, right? So this orange is just, you can think it's a name or it's a reference to this object. But I can say, well, I'm no longer your name. I'm someone else's name. It's fine. But you can't change these objects themselves. RGB, this one create an object. And the name is not pointing to this one. So the name of something and the thing itself, those are two different things. I can change my name. In fact, my official name is not Paul. It's another name. So I just go with Paul. So it's fine, right? So you must differentiate the object from the reference. Those are totally two different things. Okay? In Python, when you look at the list, when you look at the tuple, we are always manipulating those objects via their reference. We're saying objects, tuple objects are immutable, but tuple references, you can change them. Hopefully that makes a little bit more sense.
What's an example of a like tuple object? Because if this is a reference, what's a like object?
That's an object. These are objects. And you say, well, when do I have trouble? Is when you have something like this, right? When you have location 1 equals to something, right? So the location 1 means you are referring to this variable itself. And you are trying to give it a different value. This is when you're going to be in trouble. If I simulate location equals to 4 or 5, that's totally fine. But you are, this statement, you are trying to change the value of this thing. That's not allowed. Any other questions? Let's see if I can find a good analogy in here. Well, on top of my head, I can't think of any examples, but let me continue to think a little bit. Let's look at this one, right? So what's going to happen here? The orange, and then this is the part that I changed. And then I print the orange. What's going to be the result? Okay, so vote in. I think we are getting this one, right? So a majority of us voted for D. That is the correct answer because tuples are immutable. You are trying to change a tuple. This thing appears on the left side of equal sign, or you're trying to assign new value to one of the elements in the tuple. That's just bad. This is not allowed. We're not changing orange. We're changing the object pointed by orange, if you look at something like this. Okay. So this is why it's bad. Questions about this part? Okay. So let's look at the other examples. I think my camera just turned off. There we are. Okay. The last part for today is like a demo. Like how do I process pictures? In here, we have provided a library of functions that you can use to process images. So this is called CSE 8A image lib.py. So it basically defines some of these functions, and I will open it up and I'll give you a quick demo of what it looks like and how to use it. Okay. So let's do this. Wednesday, sorry, Tuesday. This is the image library. So it's called CSE 8A image.py. Okay. And it's available to you. You can use it. Okay. You don't have to worry about the body of these functions, like how we write it. You don't have to worry about it. We're just looking at what each of the functions do. Okay. The first thing, load the image. This one would allow you to say you have a picture. This one would allow you to read that picture into your program. And you're gonna return, this one is gonna return a grid of tuples. A grid of tuples is basically a 2D list of tuples. That's what you have. Okay. So this is the load. The other thing is, okay, so if I have a picture, I already processed it, I want to save it as a picture, you can save this image, which is a 2D list of tuples, and then into this file name. So this is save image. Next thing is to create a blank canvas. You say, I need to create a picture of 200 by 200. Then you call this function by saying, what's the height, what's the width, and what is the color of your canvas? You say, I want to have a pure white canvas, I want to have pure green canvas. So you provide the color, and the color is specified using RGB as a tuple. Okay. These two would give you the dimension of the image. So what is the height of this image? What is the width of that image? And summarize, this function is not widely used, but this one would print out the basic information of the image. And this image is a 2D list of tuple. It's basically like how many pixels there are, what's the width, what's the height of the picture. The last part, this is image string to file. It's gonna print out this 2D list of tuples as a TXT file. So it is mostly for debugging purpose. This is mostly for debugging purpose. Okay. So these functions, they are freely available to you. For PA4, PA5, you're gonna need to use them, and you basically can borrow them directly. Okay, so let me give you a quick demo. Okay. Let me create a file. Demo.py. Okay. In order for you to use this CSE 8A image.py, you got to import. We normally import directly from CSE 8A image import asterisk. From this file, import everything. And now I'm ready to create a file, like process a picture. Let me just take a screenshot of everyone in here on the Zoom session right now. Okay. So let me take a screenshot really quick. Where's that thing? There it is. Okay. So let's take a screenshot. Well, it didn't work. Let me try again. There are a lot of things in here. So, all right, one more try. So this is a screenshot of everyone who are here right now. Where is that one? All right, so this is a picture of everyone who are here right now. Okay, let me save it. We can save it on the desktop. Let's say this is our sample.jpg, right? It's a picture. And normally this picture, you should upload it in here. I'll upload the picture from my desktop. So that's what we have. This is what we have for today, right? I may have missed someone, maybe of 20 people. So let's try to process this picture, right? So okay, what does it look like? So the first thing you can do is you can load this picture in. Let's say load image. You provide the file name as a string, so sample.jpg, and you save it. So the return value, you capture it. You say zoom pic equals to this, right? So you load it up, and now you can print like how many, the height of the picture. Say height is the height of this zoom picture. Print width is the width of this picture. Let's run this, right? So Python demo.py. The height is 878, width is like 1296. So it's about 1,000 by 1,000. It has about a million pixels. Yeah. So that's what we have. Now what? Yeah. So you can also save, like I said, I'll create a duplicate. So you can say save image. I say save this zoom picture as, call this as a backup.jpg. I want to create a duplicate, save as a backup. If you not run the code, you see on the left side, there's going to be a backup.jpg, which is going to be exactly the same as this sample.jpg. I just created a copy. It's not fun, but you can do it. Yeah. Other things like this create picture, right? So there's this create image. I say, let me create a 500 by 500 picture. And what's the color? Let's say I want the color to be yellow. We just learned how to create a yellow pixel. Every pixel is 255, 2550. And then I will save it. This one would create a 2D list of tuples. I'll say this is my yellow canvas. And then I will save it as a picture. Save image, save this yellow canvas as my yellow.jpg. If you now run the code, you'll see my yellow.jpg. This is just a 500 by 500 yellow picture. And that's it, right? If you change this color into like red, then you create a red pixel, red picture. So let's run it. My yellow is still yellow, right? Just be careful when you use add stamp to open up a picture. If this picture got changed, it doesn't automatically refresh. You close it and open it up again. This is when you refresh a changed picture. So it's not all pure red. Any questions about this? Well, none of them is too exciting, right? So we create some pictures, create a blank canvas. So what? You can process pictures. So we haven't really talked about how to do it. Let me just give you a quick demo. Okay. So what can we do? What can we do on this picture? This picture is not too exciting. You can see my picture in here. I think Connor's picture is in here. There's a cat. There's a space shuttle, right? So how do I do it? Is there an interesting fact we can do? How about we create a filter? right now this is black. This is like color picture. How about we create a filter to make it grayscale? And so we have so many black in here. So it really grayscale doesn't make it interesting. Let's see, is there a special effect that we can do? We can, for example, okay, not too fancy. So I'll just create, like, I'll get rid of all the red components here. So no more red. Then all you need to do is say for the row number in the range of the height. Let me see. Let's say h equals to the height of this zoom picture. W equals to the width of this zoom picture. So for row number, row is related to height. For column number in the range of the width, I will unwrap RGB from this pixel, which is zoom picture, row number, column number, and I'll just get rid of all the red. 0 GB. And that's it. Whatever your red used to be, I make it 0, but I keep the original G, the original B. Again, I'm not changing the tuples. This is unwrap, and I create a new tuple, let this reference pointing to it. And now I can save this image. Save this zoom picture. I say no red .jpg. If I run this code now, you see there should be a no red .jpg, and I don't see any differences. Did I make a mistake? Let me see. We have a sample.jpg. I must have a typo from, we load it. We say the height, we say the width for RC H and the RC, I see. The issue is I have kind of, R is both a red and row number. That's not a good idea. I say for row number, column number, so it's easier. So there's no conflict. For the row number, for the column number. That's it. Okay. So let's run it. This should be the no red. You can see all the red components of this picture is changed. There's no more red in here. All the red are filtered out. It looks slightly different from before. You see all the red components are totally removed. You can also do other things like for example, I want to copy this region to cover Andrew. Like I want to copy me to cover Andrew. It's a little bit tricky, but I think it's doable. Okay. Assuming these are nice grids, so I'm going from, the row goes from 0 to h divided by 4. The column goes from, the column goes from 1/4 to 2/4. I'm just trying to copy this part in here. Let's see if it works. So you get this thing, now the other part that I will copy it to is Andrew's row is one more than me, column is also one more than me. So row number plus h divided by 4, column plus width divided by 4. And I just copy the RGB. So I get the RGB, I copy it to the right spot. Let's say this one, let's say call this change.jpg. Right. So you can do some pretty interesting manipulations. There's change.jpg. It's not perfect, but you can see I copied this region over there. I think I'm off a little bit. It's just because it's not a perfect grid. But I can probably reduce, just duplicated this region somewhere over here. You can do many other things, and that's what we'll be doing for the next 2 weeks or so. Okay. So this is the part where you can manipulate pictures and do many things. Load is read in the data. And then you can use nested for loop to manipulate each pixel depending on how you want to take care of the range. Save is something that you can use to save the data. Create image is create blank canvas. The last part is this save image as like save image as text. So I think it's called string image to text. I can't remember the exact name of that function. Image string to file. Okay. If you say image string to file, you say I have this zoom picture, save it as something.txt. I say like pixels.txt. If you call this function, what it's gonna do is it's gonna create a txt file and print out the colors of each pixel as RGB values. It can print up to the top 20 columns by 20 rows. So it's like 400 pixels at most, because pictures can be very big. So if you do something like this, if you run the code in here, you're gonna see didn't run the code. You see there's this pix.txt. If you look at it, these are the pixel values from our what's this called? Sample.jpg. So if you look at this one, what's the color of that first pixel up on the upper left corner? It is 219, 220, 222. So if you look at it, in fact, there is a pretty bright pixel up on the upper left. We can't see it, but there is one. It's pretty bright, right? But look at the first row is pretty bright, if you look at it. And then things get close to black. These are very small RGB values. So they are close to black, but they are not pure black. Okay. And go on. So this would give you like a 20 by 20 grid of what it looks like on the picture. So what's the big deal about this? A lot of times, if you say, I want to remove the red, I would say, okay, remove the red component of a picture. When you say, okay, looks like the red is gone. But you cannot just eyeball it, because human eyes are not sharp enough to tell the things apart. So if you say, okay, this is what I have, let me go back to the red, right? So this is no red. I say, okay, I can't remove all the red. This is the original picture's RGB value on the upper left corner. And I run the code and I like, oh, there's no red. Looks cool, right? Looks good. But am I right? Did I make a mistake? This is when you use this save image, image string to file. You say, now let me save this picture. I say like after.txt. If I do this, it's gonna save the updated pictures top 20 by 20 region into a txt file. Oh, sorry. I think I made a mistake. Row, column, row, column. Do it again. So you will see that there is this after.txt. If you look at after.txt compared with the original txt, you see the original. Let me see. Can I do them side by side? Can't seem to be able to do that. But the idea is, if you look at this is the original, it's 219, 220, 222. If you look at after, it's 0. So the red component is removed. If you look at all these things, all the red are zeroed out. The other parts remain unchanged. So this is when you know for sure, okay, my code works. Because if you make any mistake, you say, oh, I forgot, it's not 0. I type in a 10, just a typo. If you simply eyeball the picture, you're not gonna see the difference between this one and the original one. Right? It looks like okay, it looks okay. Okay, I know there's no red, but if you look at after, that's incorrect. So it's useful if you try to debug a image processing algorithm to say, okay, is my result accurate? Because this is how we grade your work. We don't say, oh, we eyeball your picture. No, we look at every pixel in the resulted picture and see if every pixel is exactly the same as the correct answer. If you are just off by 1, then your answer is wrong. Okay, so just be careful in here. So using this image string to file, you can examine every pixel's value in your sample result, at least the top 20 by 20 region, and see if everything makes sense. Okay, that's what we're doing here. Any questions about the demo? About how to use the CS8A image library?
Is this gonna be on the midterm?
Everything we covered from day 1 to the end of the day today may appear in the midterm. Okay. Any other question? They may appear doesn't mean they will appear. I just want you to know that that's how we have the cutoff by the end of the day today. Okay? Obviously, you haven't done any assignments on using this library. I won't ask you, hey, write this one to remove all the red. I won't ask you, but potentially I can ask you what each function does, right? So, but officially it's from day 1 until the end of the day today. All right. Now, the last practice for today is this 2D list of tuples. This is a picture, right? So you have this hierarchy in here, okay, hierarchy in here. If you look at it, it's for this part, you can see the outermost structure is a list. Each element in this list is a list. So it's a 2-dimensional list. Each data in here is a tuple. So let me ask you, how many pixels are there in this image? This 2D list of tuples. How many pixels are there? Let's vote in. So a lot of us said B, there are 6 pixels, right? If you look at there are 6 tuples, that means there are 6 pixels. So that's it. Okay. Each tuple is a pixel. This is a pixel. Okay. Now, what's the height of this image? What's the height? Height is how many rows you have. All right, I think we have a super good consensus is 3. The height is 3. The number of columns is 2. If I print out image 1, what do you think will be printed out? This will be our last vote for today. Image 1. We disagree with each other quite a bit. Remember, indexes always come from 0. We start from 0. Yeah. All right. So if you look at it, the majority is B. Let's check. 0, 0 is 255. So the first dimension, image 1, it means the outermost, the highest hierarchy is this part. Right? So 1 is referring to this. This is the list. And then 1 again, index is the first element. So it's B. Remember, this is row 0, row 1, row 2. Okay. So it's basically a hierarchical structure. The outermost hierarchy, so image, is pointing to a list. This list would have 3 things. This is 0, 1, and 2. So this is the object. And this list, this by itself points to a list. And there are 2 things. Okay. And this 0th element is pointing to 0, 0, 0. This one is pointing to 255, 255, 255. That's how you view it. Image 0 is referring to this row. This row is a list by itself. So each of the element is a tuple object. That's how you view a 2D list of tuples. And when you say image, for example, 0, 1, what do you mean? Image 0 is you are referring to the first level. And then 1, you're referring to the second level. I hate this. Why can't I just it keeps popping up? So annoying. But the idea is this. So you are looking at this is the first element in there. So 0, 1, 0 is this arrow, 1 is this arrow. So you're looking at that tuple in there. Okay. Any questions about this? All right. Now, how about I do image 1, 1, 1. Can I even do this? The answer is yes, right? 1, 1, give me that tuple. And then index 1 again will be 0. This one equals to 0. So we are going down the level one step ahead using the index. This one, go down one level, go down another level, go down another level. And if you do one more index, you're gonna be an error. You're gonna see error because you already reached the integer level. You cannot index it anymore. Any questions about the tuples or pictures? All right.
I have a question.
Okay, go ahead.
If you do just like image index 0, does it give just the whole list
Yeah.
of 2 tuples?
Yeah.
Okay.
If you print out image 1, you're gonna see the whole list, the first row. But that's the first row. That's we have a 0th row, then the first row. Yeah. Any other questions? All right. So for the third session today, it's basically QA. Okay. So I'll be here. If you have questions, feel free to ask. If you don't have questions, feel free to use the third section to prepare for the midterm tomorrow. Okay. I will stop the recording. Okay, we're gonna have a break. We'll come back at 1 o'clock, and then I'm gonna stop the recording. And then I will just wait for questions here. Okay. So let's take a break, and then we'll come back for QA. Okay. If you need to leave, feel free to go now. If you don't have any questions, but if you have questions, wait a little bit. I will answer all your questions. Okay. So break time. Come back at 1 o'clock. Thank you.